1.7 power rules. Going through the first one here, x to the power of m, if that's in brackets and we have an n outside, then our rule for today is that we can just take the two exponents and you can actually multiply those together. Do you remember last day we did the product rule where the two, if two powers with the same base are being multiplied, we add the exponents, and we also did the quotient rule, right? Where if they're being divided, then we subtract the exponents. So today, this is the power rule where we multiply them. So what do we get for the first one here? 5 to the, well, what do we do with the 3 and the 2? I think so. 5 to the 6. Yes.
How it works is because, like we say, we operate in the bedrooms. So we know what's in the bracket. So then.
Oh, I'm so glad you're bringing that up, Alex. So remember BEDMAS, everybody? According to BEDMAS, we would do the stuff that's in the brackets first. But in this case, that doesn't apply. When you have two exponents like this being multiplied, we can just multiply them together. So we don't have to do 5 to the 3 first and find it as a number. This is sort of like a shortcut. We're learning a shortcut today. Good? Who doesn't like shortcuts? It makes your life easier, basically. Are you okay with that? Yes. Exponent times the exponent. Yeah. So then, you know how this goes. If for the next one I make it a little bit harder because there's variables there, then what do we end up getting? A to the power of? A to the power of? Sure, Liam, would you mind? Thank you. Do you see we would multiply these so we would get 2ab, everybody?
Yeah.
Yes.
Is that how it works? Like, because we're powering exponent, technically it's kind of like multiplying 5 by itself. You know, multiplying the exponent by each other is kind of like.
Yeah. So, you know how we did b times 2a? We could have said 2ba, but we normally put them in alphabetical order. It's not wrong if you do it the other way, but usually that's the correct way, is to put it alphabetically. And then how about when we get something like this? If we have an n on the outside and the whole thing is in brackets there, x over y, what does that end up being? Thanks, Liam. Can you open it, please? X to the n over y to the n. So what happens is we distribute the n up there and right there. So if we had numbers in there, well, we'll see that next. But do you get the idea with that? If you have fractions and then you have an exponent outside, you have to distribute that exponent to the top and the bottom of the fraction that we have. So maybe by looking at that, somebody want to tell me what we would get in this example here? Four squared over 5 squared. So this 2 has to go to the top and the bottom. And what is 4 squared? Ouch, it's that kind of day. What's
4 squared.
Yeah.
4 squared. 4. No. No, because it's, I thought you said it's 40 pounds. Oh, even sorry.
I'm very concerned. Over 5 squared, what's 5 squared? 25, good? So that's what we would end up getting. So the key here is just knowing that the exponent gets distributed to the top and the bottom. Okay, then how about when we have all sorts of things going on like this? First thing is I want to get rid of the brackets. What do I get when I get rid of the brackets? At the top, I'd get x to the power of 6, and at the bottom I'd get y to the power of 15. Is there anything else I could do there? No, the bases are different. There's nothing I could reduce. I just have to leave it like that. So this is what would be our answer. How about this one? Oh, there's a lot going on there. I think, well, we can go step by step. Let's just worry about the top for a minute. Just at the top, what would I end up getting? What do I do with these? We keep the base the same, so -2 to the power of 8. We multiply them, right? And same thing at the bottom, I need to multiply this and this, so I'd get -2 to the 12. Are we done in this case? There's a bit more happening. Same base, top and bottom, so what can we do, or what would be my next step there? Anybody? Alex?
Well, I'm sure we have to first divide exponents before we simplify.
Oh, we can do that. Either one is acceptable. So we could have subtracted these within the brackets first and then multiplied by 4. Or we could do it this way where we're multiplying it out by the outside bracket, the outside exponent first, and then simplify it. So either one is acceptable. Good? What do we do in this step if this is how we've chosen to go about it? What do I do with the 8 and the 12? Just like yesterday, we would do 8 minus 12. So we would get -2 to the power of, what's 8 minus 12? Yeah, -4. And this is getting a little bit tricky because there's a negative in the brackets and there's a negative for the exponent. We don't want a negative exponent. How do I make this positive? We flip it. Good. We flip it and take the reciprocal. So 1 over -2 to the positive 4. Is it reasonable to take 2 to the power of 4? Do we know that off the top of our head? That's a base of 2. That's reasonable. First of all, is the answer going to be positive or negative? If we have a negative in the brackets and this number up here is even, it's going to be positive, so I can just pretend it's 2 to the 4. What is 2 to the 4? 2 times 2 times 2 times 2. What is that? So we get 1 over 16 as our answer.
That was easy.
Did I pull that off in 10 minutes?